the reciprocal identity. The cosecant of theta is equal to -5/2. I don't see any Pythagorean triples in our future. And they give you, in radians, that this is an angle somewhere between 3π/2 and 2π. So what quadrant are you in?
Quadrant 4.
Yeah, you're sitting in quadrant 4. This tells you that your angle theta is that big angle there. So this makes it a little trickier to predict what will happen when you double an angle this large. The larger the angle, the larger the range of possibilities when you double it. We're definitely going to wind up going around a circle into another rotation around the unit circle. All right, nobody likes cosecants. What do we change this to?
Sine.
Sine, very good. It's the sine of theta, excellent, is -2/5. Then we're talking about a triangle down here. What does this triangle look like if I keep the orientation? There's my, well, I'm going to keep writing theta like that. Looks like Pac-Man, doesn't it? The reference angle, of course, is in here, but bless you. So I'm going to treat that as a -2. The hypotenuse is always positive. What have I got up here? I've got 5 squared, 25, minus -2 squared, which is going to be +4. So I have the square root of 21 for my adjacent side. So that means my cosine of theta is +√21/5. I know it's positive because I'm in quadrant 4, and because that's what I got. Okay. Do we have enough information to find our sine 2 theta, cosine 2 theta, tangent 2 theta now? I think so. Sine 2 theta is the most straightforward. So 2 sine theta, cosine theta, which in this case is going to be 2 times -2/5 times the square root of 21/5, which gives me -4√21/25. I don't see a good way to simplify that. Anybody else?
No.
Okay. Tell me something about our final angle. In what two? It has to be in one of which 2 quadrants?
3, 4.
3 or 4. Why?
Because that's where sine is.
That's where sine is negative, because sine correlates to y, and that's where y is negative. Excellent. Who has a preferred cosine 2 theta identity?
The top one again.
No, it's 2 different ones. There's a 1 minus 2 sine theta, or sine
All right.
squared theta.
1 minus 2 sine squared theta. Danny, there's nothing wrong with you sticking with cosine squared minus sine squared all your life. May be useful to recognize these on some identities later, but
Yeah.
let's try one. Let me speed things up. All right, the sine was the slightly less ugly one. It was the -2/5, and we'll be squaring that. So that becomes 1 minus 4/25.
No,
Positive?
they become 8/25.
I forgot the 2, thank you. It does, it becomes 1 minus 8/25. 1 is 25/25. 25 minus 8 is 17. So I'm getting positive 17/25, correct? Okay, what quadrant is this final angle in? 4. Okay, so to get into quadrant 4 after twice around the unit circle, I would have had to have gone 360 plus another 270, which takes me to 360 plus 270. I am tired today. That takes me to 630 degrees, right? That's right here. Okay, so I must have started with at least. So one thing I know, this original angle theta was at least 315 degrees, because when I doubled it, I got somewhere past 630 degrees. I don't know why you need to know that, but we now know that this angle is between 315 and 360. Did you need to know that? No. Is it interesting to me? Yes. So we've narrowed down our range of our original angle. Tangent to theta then, I hope you guys are starting to see a pattern.
Yeah.
I'm going to put this over this. It'll have the same denominator. It had better because now we're talking about a new triangle, and sine and cosine better have the same hypotenuse. It's going to be this numerator over this denominator, so it's going to be negative 4 root 21 over 17. And that pattern should follow to all three answers, unless some simplifying made it look different here. Any questions on number 26? We good?